Page 4 of Properties of Curves. Number 11. Find where the tangent to the curve y equals x cubed at the point where x equals 2 meets the curve again. So here we have two steps. One is we're going to find the equation of the tangent line. After we find the equation of the tangent line, we're going to find the intersection between the tangent line and the original function. We'll find that there's more than one point where they intersect. At least one of the points is going to be the point where it's tangent, and there's probably going to be at least one other point, right? So let's do that. We're going to find the tangent line to this function. So we write down the point slope form, and then we're going to find the three ingredients. We're going to find the y1, we're going to find the x1, and the m. Now the x1, they already gave it to us, it's 2. How do we find the y1? We just plug the 2 into the original equation. So 2 cubed is 8, so our y1 is 8. Last thing we need to find is the slope. The slope, of course, is the derivative of the original function. So it'd be 3x squared. And now we're going to put the 2 into the derivative equation, and we get 3 times 2 squared, which is equal to 3 times 4 is 12. So our m value is 12. So our final equation is y minus 8 equals 12 times x minus 2 in parentheses. Now we just need to figure out when does this line and the original function intersect. In order to do that, we need to change the point slope form into a form with y equals by itself on the left side. So let's do that. All we need to do is add 8 to both sides, and it's already ready. Now we can set the tangent line equation equal to the original function, and then we'll have an equation which we can use to figure out when do these two intersect at each other, because then we want to know when the tangent line meets the curve again. So we have 12x minus 2 plus 8 equals x cubed. Okay, so let's expand and combine like terms. So we got 0 equals x cubed minus 12x, and then this would be minus 16 plus 16, so it would be like that. Okay, and at this point, you're not expected to be able to find the roots to a cubic, so we're going to do that with the calculator. One of the ways you can find out the solution to this equation is you could use poly-SMLT, which is here at number 2. The way you use this is, first you just hit enter, then you choose poly root finder, and this is a cubic, so it's a third order, so we choose 3. We hit enter on 3, press next, and then it asks us for the 4 coefficients, 1, 2, 3, 4. So the coefficients are going to be 1, 0, negative 12, 16. 1, 0, negative 12, negative, make sure you use this little negative sign, negative 12, and the last one should be 16. Notice that there's no x squared term, and that's why I put a 0 there. Solve. So my possible solutions are negative 4 and 2 and 2. So we know about 2 because that's the tangent line location. So the negative 4 is the other location. So the other location is going to be negative 4. If we want to find out the y coordinate that corresponds to that, we just plug it into x cubed, which would give us negative 64. So the point would be negative 4, negative 64. Number 12, consider the function x squared plus 4 over x squared. Let's just rewrite this. Later we're going to take the derivative, so we're going to rewrite it like that. It's the same function, okay? Find the derivative. Oh, they already asked us to find the derivative, so first thing we're going to do is we're going to find the derivative of this function. It's already in a nice format for us to use power rule. Okay, and let's simplify. 2x minus 8x to the negative 3. If you'd like to, you could write it as minus 8 to the x cubed in the bottom. Okay, find the values of x at which the tangent to the curve is horizontal. In other words, when does the derivative equal 0? When is the tangent horizontal? So to find that, we could set the derivative equal to 0. So let's try that. Let's see, let's do it in this form here. 2x minus 8 over x cubed equals 0. Now, in order to solve this equation, it would be nice if all the x's were in the numerator. What if we multiplied everything by x cubed, both sides by x cubed, in order to get x cubed in the numerator? By the way, remember, x cannot be 0 because we have x in the denominator here before we go off and change the value of everything. Okay, so we change the value of the left and the right side by multiplying both sides by x cubed. By doing this, 2x becomes 2x to the fourth, and then 8 over x cubed just becomes 8, and 0 is still just 0. Now we can solve this by factoring out a 2. Factoring out a 2, and then we'll have x to the fourth minus 4 equals 0. X to the fourth minus 4 equals 0. That is equal to x to the fourth equals 4. X to the x is equal to plus or minus the fourth root of 4, which is equal to plus or minus square root of 2. Okay, so those are the values of x, which the derivative is 0. Show that the tangents to these points are the same line. Okay, so we have plus square root of 2, minus square root of 2. Now what we're going to do is we're going to show that they're the same line by putting both of these x values into the original y function. So the first time we do it, we're going to have negative square root of 2 squared plus 4 over negative square root of 2 squared. And then we're also going to do that with positive square root of 2 squared. And now you can easily see that in both cases, the negatives cancel out here. So both of them are going to give you the same value. It's going to be 2 plus 4 over 2, which is equal to 4. And 2 plus 4 over 2 equals 4. So they both have a y value of 4, which means that the horizontal tangent in this case is y equals 4. And the horizontal tangent in this case is also y equals 4. Okay? All right, number 14. Find the equation of the tangent to this function at the point where x equals a. Hence, find the equation of the two tangents from 0, 0 to the curve. Okay, so first we'll just do the first part and then we'll try to understand the second part. The first part says find the equation of the tangent line to this function, but it doesn't tell us at exactly which point. They just give us this a value. We're going to put that in for x, okay? All right, so first thing we're going to have to do is we're going to have to write point slope form. And we know that our x1 value is going to be a. Our y value is, or y1 value is going to be a squared minus a plus 9. And that's what we're going to put in for y1. Last of our m value is the slope. We need to find the derivative, which is 2x minus 1. If we put a into it, it's going to be 2a minus 1. So our m value is going to be 2a minus 1. All right, let's plug in the y1 now. Y minus a squared minus a plus 9 equals 2a minus 1 times x minus a. All right. Okay, so now this is the general form of the tangent line. And now what they're saying is, okay, this describes any tangent line to the curve. So there's an infinite number of tangent lines to the curve. Let's say, since this is a parabola, any tangent line would be, like this, or like this, or like this, or like this, right? Any tangent line is described by this equation, okay? But there's only two tangent lines, which go through 0, 0. Okay, so in order to find those, we would need to be able to plug 0, 0 into the x and the y value, and not the x1 and the y1 value, literally the x value and the y value, we should be able to plug in 0, and then the a values that make that true would be the x coordinates that we want here, okay? So what we're going to do is we're going to put 0 in for y, 0 in for x, and then we're going to solve for a. Okay, so this is going to be negative a squared plus a minus 9 equals negative 2a squared plus a. These two cancel out. We can combine these two. I'll add 2a squared to both sides, so I'll get a squared on the left. And I would add 9 to both sides, so I'll get 9 on the right. So a is equal to plus or minus the square root, or no, square root of 9, right? Which is equal to plus or minus 3. So a is equal to plus or minus 3. Those would be the x values where the tangent line would, those would be the x values where the tangent lines that go through 0, 0 would hit the curve, okay? Now what do they want to know? Hence find the equation of the two tangent lines. Okay, so we could find the tangent lines by putting in plus or minus 3. Okay, so first I'm going to plug negative 3 in here, so I get y minus 9 minus negative 3 plus 9 equals 2 negative 3 minus 1 times x minus negative 3. And then the other one would be with positive 3. So it would be y minus 9 minus 3 plus 9 equals 2 times 3 minus 1 times x minus 3. So let's simplify both of these. So this would be 9 plus 3 plus 9, which would be y minus 21. And this would be 2 times negative 3, negative 6, minus 1, negative 7, x plus 3. And then this one would be y minus 18 minus 3 is 15 equals 6 minus 1 is 5, x minus 3. Okay, so those are the equations of the two tangent lines. And then it says, state the coordinates of the point of contact. Oh, the point of contact of each one, it's going to be 3, 21 and 3, 15. Okay. All right. Last one on the page, number 15. Find the equation of the tangent to y equals e to the x at the point where x equals a. Hence, find the equation of the tangent to y equals e to the x, which passes through the origin. Okay, so this is kind of a similar problem to the previous one. We're going to find the general tangent line to y equals e to the x. We're not going to specify exactly what the x is. And then we're going to use that to find when it goes through 0, 0. It's very similar to the previous one, maybe even easier than the previous one. So we know that our x1 is a. We know our y1 is equal to, oh, do you need me to write the point slope form? Okay, we're going to fill this in. x1 is a, y1 is equal to e to the a. What is the derivative of the m value? It's going to be, the derivative of this function is e to the x, right? So when I put in a in for x, it would just be e to the a also. So this is a quite easy to find the three ingredients. We're done. Okay, so this is the tangent line equation. We want to know the equation of the tangent line that goes through the origin, which means we're going to plug in the origin, 0, 0, into this equation, and then we should try to find the a values which make this true. Okay, and e to the a equals e to the a times a. The negatives cancel out. e to the a's can cancel out, and we're left with a equals 1. So the answer is, let's see, a is equal to 1, y1 is equal to e to the 1, which is e, and then y dash is equal to e to the 1 also, which is also e. So our line equation would be y minus e equals, the m value would be e x minus 1. Okay? Yep, that's it.